Hello, I'm Maya Samanti, and today I'm going to be talking about the history and physics behind the most common type of air travel, planes. To this day, the debate over what the first flying machine really was continues and continues strong. Some argue for Lebris's horse-pulled flying machine of 1868. Others say the Gifford balloon, which dates back to 1852 and is known as the first powered airship. Or what about the governable parachute created in the same year? While we're still unsure about which of these really qualifies as the world's first airship, everyone knows about the world's first airplane. In 1903, Wilbur and Orville Wright made history when their prototype airplane lifted off the ground and stayed in flight for a full 12 seconds. The brothers continued changing and improving their design until they were able to fly over 24 miles in 38 minutes in 1905.
They all laughed at Wilbur and his brother when they said that man could fly. They told Marconi.
In the next decade, airplanes would go on to see changes in both design and function. They were mostly used for warfare at the beginning, as World War I began in 1914 and saw the first combat airplane go into battle. But in 1918, the American Postal Service created their first airmail service, shipping letters on small individual planes. And in 1919, the world's first sustained international flight service was established, bringing planes to what they are most commonly used for now. In this day and age, airplanes are crucial as a fast means of travel, but with the easy accessibility of air travel, we tend to forget how much work it actually takes to fly. So, what really goes into getting an airplane off the ground and keeping it in the air? It actually utilizes multiple laws of physics. In order for a plane to fly, there has to be air moving across its wings. Like a bird's wings, the wings of an airplane are made in the shape of an airfoil. Airfoils are useful in lift because their shape manipulates the airflow around them. One of the major theories at work here is Bernoulli's principle, which states that fluid velocity increases as pressure decreases. Because the top half of an airfoil is curved, the top half is longer than the bottom half, forcing the air traveling over the top half to move faster. This causes a decrease in pressure, which creates lift.
We're breaking free. We're soaring, flying. There's not a star in heaven that we can't reach. If we're trying, yeah, we're breaking free.
Lift is only one of the 4 forces acting on an airplane in flight. The other 3 are weight, thrust, and drag, though we may know weight better as force of gravity and drag better as friction or air resistance. While studying forces, we learned that for an object to move at a constant velocity, the sum of the forces acting on it must equal 0. The standard formula for a force is force equals mass times acceleration. While summing the forces in a given direction, the sum of those forces must equal mass times acceleration. And if acceleration is constant, then it will be equal to 0, making the right side of the equation equal to 0. Acceleration needs to equal 0 so the plane does not change in vertical velocity and altitude. Therefore, lift must be an equal and opposite force to weight. Weight is represented by the formula W equals mg, in which m is the object's mass and g is acceleration due to gravity, which equals 9.81. So it is constant for any given object. Thus, lift needs to be adjusted to match it, which is where the airfoil shape of the plane's wings comes into play. Thrust and drag also need to cancel out to keep horizontal velocity constant. When traveling at such high velocities, air resistance gets pretty big to say the least, so thrust needs to be generated. This is why airplanes have such big engines, to propel them forward and create enough thrust to cancel out the drag force. All of this is to keep the airplane moving in the right direction and at a constant velocity to prevent some sort of disaster from happening. Although we may take for granted how much work goes into flight, I hope today you learned something about how far air travel has come and how far it can take us.